Hello friends, welcome back to Too Attractive. In this video, we are going to be discussing about how do you solve energy and power signal problem. Not only that, you will also be knowing how to easily solve with some kind of shortcut or trick. So which means that there are two ways. At first, you can easily identify with some tips and tricks how to solve it, or two, we are going to see how to solve a real example from beginning to end. Alright, let's go. Firstly, what we need to understand about this concept is that an energy signal, right? An energy signal are signals with finite energy and zero power. You need to take note of this stuff. We're going to be discuss more about that, right? It has a finite energy but has zero power. So whenever you have a signal and it has a finite energy, like having a value 1, 2, 3, or whatsoever, but the power, when you try to solve for the power is zero, then that signal is an energy signal. Why for power signals, right? Power signals are signals with finite power, right? But what? Infinite energy. Which means kind of the difference between both of them is that we have zero power for energy, but infinite what? Energy for power. You get the point? So now let's look at tips on how to solve a signal easily, to even know like a signal, to identify quickly that a signal is an energy or power signal. That's what we're going to do now. The first point we need to take note here is that if we have a signal x of t, right, and the amplitude of the signal, which means the value of the signal x of t is 0, right, as t tends to infinity, then that signal is an energy signal. Let's look at this example and see what is that. If you look at this signal now, this signal is it has unit step, right? Remember that u, as we discussed in our video on basic signals, u of t is what? Step signal, right? And this is how the sketch of a step signal is, right? It has a jump 1 and keep going to infinity. That is u of t, right? So if this signal is u of t, right, and e to the negative 3, you know this is exponential, right? So this is kind of the magnitude, this kind of the amplitude of the signal. You get the point? So if this is the amplitude of the signal or the value, then we take it out, right, and leave this step function alone, and we'll take this first part only. You get the point? So, and we take the limit as it tends to infinity. So, by taking the limit of this function as it tends to infinity, what are we going to get? So, let's do this. E minus 3. So, we substitute t, which is present here, with infinity, right? And you know, anything multiplied by infinity is what? Infinity. So, e to the negative infinity is same as e to the infinity. And anything to the power of infinity is 0, just because the fact that e to the infinity is 0, e to the 0 is 1. That's the basic concept, right? So if you can see, e to the infinity is 0. So now, which means that the amplitude or the value of this signal x of t, right, is 0. So if it is 0 as it tends to infinity, then the signal is said to be an energy signal. You get the point? Let's look at more concept on that. So the next thing is that another tip here is that any periodic signal, non-periodic signal are considered to be an energy signal. What do you mean by non-periodic signal? Any signal that has like a shape like this, you know, right, is not periodic, like a sine wave that keeps going. Then such kind of signal is said to be what? A non-periodic signal or aperiodic signal. So whenever we have an aperiodic signal, because the concept here is that the area under the curve is finite, we can at some point we can demarcate and find a value. But for kind of, you know, non-periodic periodic signal, it keeps going to infinity. But for aperiodic, that's not. So we kind of took point. If you look at the signal, let's say u of t that we made mention, u of t is not kind of it's not a periodic signal, it's a non-periodic signal. In essence, then definitely that's will result in what? An energy signal or something like that. If you look at the exponential we discussed also about, exponential usually goes this way. You understand? This way or this way. That's for exponential. So if it is going, that is plus, it is rising. If it is going down, it is decreasing, right? So you know it's not kind of continuous that way. It has a limitation and it gets stopped at some point. Now, another thing here is that the one we discussed first is for the energy signal. What about power signal? We said if the amplitude, right, of the signal x of t, as we did for the first one, is constant, meaning we have a value at t tends to infinity, then the signal is said to be a power signal. Let's look at this example. You know, this is a sine wave. Let's draw a sine wave. right? It keeps going to infinity, right? And they say the amplitude is 4, as you can see. So since the amplitude is kind of constant, is 4, then definitely there's not, if you take the value 4, there's no way you can even apply a t tends to infinity, right? Then definitely you can consider this to be what? A power signal. You get the point. So let's have more example. Let's look at this first. Periodic signal are considered as power signal. Remember, non-periodic signal are considered to be energy signal. You get why periodic signals are considered what? As what? Power signal, as they have constant amplitude. More example on that. We have 5 sine omega t. We have 3 cos 2 omega, t, and so on, like tan 4t, right? Or omega t. In this case, as you can see, the amplitude is 1. It's quite constant, right? So you can get the concept about that. Let's look at more on this. Now, we've discussed about energy and power signal, right? What are our signals that are neither power nor energy signal? For instance, a ramp signal, right? A ramp signal is denoted in mathematics form as R of t. So the signal is said to neither be an energy or non-power signal. And the reason being is that the reason why it is neither an energy signal or power signal is that R of t is defined as Tu of t. If you go back to our video on basic signals, right, you will see Tu of t as what? The function, because this is how it goes. It tends to infinity, like in a slopey form. So at any point we have a value of t, right? It keeps going. Now the thing here is that if we take this and we test it to infinity, as we usually do, like if you take the function and the first part, then you test it to infinity. If it gives you what? 0, then definitely it has to be what? Energy signal. If it gives you 0, then if it is constant, then definitely it is what? Power signal. So in this case, let's take it. We take t as our main concept, right? So let's take t as it tends to infinity. We see it results what? In infinity. So in other words, if it results in infinity, then definitely the energy is equal to infinity, which results in power to be what? Infinity, because there's no way you can calculate for it, right? Infinity divided by constant is often what? Infinity. So it ends up giving us infinity, right? See, this is the first part. So whenever we have energy equal to infinity and power equal to infinity, they are neither energy nor power. Remember, we said from the concept of the definition of energy and power signal, we say energy signal is signal with finite energy, 0 power. Finite power, infinite power. Not infinite power, infinite energy. Not that way, right? So let's look at another example of what? Neither power nor energy signal. An exponential function, right? Is an example. Let's say e to the negative 80. If we test it to infinity, right? So e to the negative a times infinity will give us e to the negative infinity, which is equal to what? 0. So which means the energy is equal to 0 and the power also is equal to 0. So if both case is like this, then definitely they are neither what? Energy nor power signal, right? Now there's something. What if you can't easily tell from a function you are being given in an exam, you can't easily tell if it is a power or energy signal? The first thing is that know this table very well, right? You write energy down, you write power down. You now write E, which stands for energy. You write P, which stands for power. An easy way to record this formula is that, in the in alphabetical order, we have the letter E, F up to Z, which means the infinity. You can think of infinity as Z going to the last part. Now, if you can get that, the last one is pronounced as POF, P0F, POF, POF. So if you can know EF infinity, POF, then definitely you know from this table you can easily define the definition, because energy has a finite, right? Energy signal has finite energy, as we said, 0 power. Power has what? Infinite energy, finite power. You get the point? So let's look at more stuff. Assuming you are given a problem and you can't easily solve it or find the value to know whether it is an energy or power signal just by applying those steps, right? So you need to solve it. Or let's say the question asks you to solve a signal to see whether it is an energy or power signal. So in that case, you can't use that shortcut or trick. You have to solve it step by step. So the first thing here we need to understand is that energy has this formula, right? It might be kind of confusing, but I will explain it. Likewise, power is also the same. Now, there are 6 steps we need for solving any energy or power signal. Or I will say there are 6 steps to solve a signal, so you will be able to know if it is an energy or what, power, or even so, they are neither energy nor power signal, just as the example of rap we discussed. Now, the first step in solving it is that if you are given a function or signal x of t, which means when you have a signal x of t, which is the function you are being given to analyze or to solve, the first thing you need to do is that after you collected the signal, all right, you need to do something, which is what? You need to find the absolute value of the signal x of t, which means you take the absolute value. That means that let's assume x of t is equal to 2. Then definitely the absolute value of x of t has to be 2. If x of t is equal to negative 4, the absolute value has to be positive 4, because absolute removes negative, right, and turns everything to positive. You get the point? The third step you need to do is that you find the square of the what absolute value, assuming that you are given squared, right, x of t equal to 2. Then if x of t is equal to 2, the absolute value is also equal to 2. Then definitely by taking the square of 2, you got 4, isn't it? The first step here is that we need to find the integral of the squared modulus value, which means whatever we got in, we have to take the integral limit from negative t to t. You get the point? dt. Now, the fifth step here is to what? Take the limit. After you solve for this integration, you take the limit as it tends to infinity, right? Now, after you take the integration of this, you take the limit as t tends to infinity, which is going to give us energy, as you can see from the formula for energy, that it is. Likewise for power, after we calculate for the energy, which is E, right? Here is the energy, which is E. For us to calculate for power, what we need to do is that before taking the limit, you understand, we take this integration here, we divide it by 1 over 2t, which is actually the period of the signal, right? So after we divide it by 1 over 2t, we then take the limit. So the difference between power and energy signal is just this period, 1 over 2t. You get the point? So after you apply this step, then you should be able to solve any problem on what? On energy or power signal. Let's look at some examples. The first example here is x of t equal to e to the negative at u of t, ranging from negative infinity to infinity. So I'll get the first one. Solution, right? You get the point? So the first one here is x of t equals e negative at u of t, right? Now, the first thing we need to do is that we need to kind of apply the same step. So let's look at it one at a time. The first step says that after you got the signal x of t, right, you find the modulus or absolute value of that signal. So let's find the absolute value of this signal. The absolute value of this signal, x of t, is equal to e to the negative at u of t. The reason being here is that there is no negative value. Even there is, we turn it to positive, isn't it? That is the first step, right? The second step we need to apply here is that, right? We need to apply the second step. The second step here is that we need to square it, right? So we square the absolute value of this function, right? Which is what? It says you take the square, right? So it becomes e to the negative at u of t squared. Now, you know this results in what? E to the negative 2at, right? U of t r squared. Now, there is something. This will give us e to the negative 2at, right? But what about u of t? In our previous video, we discussed about the unit step impulse, the step signal, ramp signal, and the likes. Now, as you can see, u of t is also known as the word unit step signal or the if side function, and it is defined for this. It means that u of t has a value of 1 and 0 at some point. Here's what I mean. U of t has a value of 1 at 0 when t is greater than 0, and when t is less than 0, it is 0, right? So which means that when we have it in graph like this, u of t is only defined for this region from 0 to t going to infinity, right? When t is greater than 0, it keeps going. But for this region, u of t has a value of 0, but at this point u of t has a value of 1. So in that case, if u of t is having a value of 1, if you squared 1, it is going to give you the same thing. So which means u of t squared is same thing as u of t. So if u of t squared is same thing as u of t, what we need to do here is that we need to proceed in solving. The question asks us to what? The next thing is to find the integration, as we know in the steps, because we've concluded for what? This squared. Now we need to take the integration. So let's take the integration of this. Integration from negative t to t, u of negative 2at, u of t. Now, don't forget dt whenever you're taking integration. So the next thing you need to do here is that, remember, u of t is only defined from 0 to t. So which means there is no need of taking the integration from negative t to t, right? So this u of t kind of truncate this signal, because that's one of the function of what? U of t. So in this case, we take it from 0 to t, e to the negative 2at, but we are not going to include u of t because it has already what? Neglect or remove negative t to 0, right? So we just put dt. You get the point? So we just put dt. Meaning that since u of t is defined from 0, right? For t greater than 0, that means from 0 to t it is defined, then definitely we can just remove this negative t. That means from negative t to 0, it was already 0. So we go from 0 to t. Instead of taking the integration from the whole side, and at the end of the day, this becomes 0. No, we only start from 0 to t. So if you are starting from 0 to t, e to the negative 2at, we remove the u of t, right? And we just put our dt. Now, let's proceed. So for us to solve this, we said what? The integration of this kind of function is going to give us e to the negative 2at, am I right? Divided by the differentiation of whatever this is. So the differentiation of negative 2at is equal to 2a, right? If you differentiate it, so we have negative 2a. Now, remember the integration pattern? Go this way. So after you are done doing this, the next thing we need to do here is that you need to say, okay, 1 over negative 2a, e to the negative 2a, so we substitute t. Now minus e to the negative 2a, now we substitute 0. Right? So the next thing we got here is that we got 1 over negative 2a, open bracket, e to the negative 2at minus this one, whatever times 0 is 0. So e to the negative 0, right? So we proceed and say 1 over 2 negative 2a, right? E to the negative 2at. Remember this pattern, e to the 0 is 1, e to the infinity is 0. So e to the 0 is 1, so minus 1. Then we'll close the bracket. Now, after we are done finding the integral, as the question says, because here is the integration, here is where it goes and gives us this value, right? Here's the integration of that function. Or in essence, we can say the integration of negative t to t, e to the negative 2at, u of t, dt, right, is equal to what? Negative 1 over 2a, e to the negative 2at minus 1. Because that's what the integration, we follow some series of steps by removing the u of t, simplifying it. At the end of the day, we got this as the integration of this. Now, since we got this, what we need to do, which is the next step, is that we need to take the limit as t tends to infinity. And whenever we take the limit, it is going to give us what? Energy. So we are close to solving for what? Energy. So E is equal to what? Limit as the t tends to what? Infinity of what? Negative 1 over 2a, e to the negative 2at minus 1. So what we need to do is substitute wherever we see t with what? Infinity. So that's going to give us negative 1 over 2a, open bracket, e to the negative 2a times infinity minus 1. Remember I said earlier that e to the infinity has to give us what? 0. So if that's 0, then e has to be equal to negative 1 over 2a, open bracket, 0 minus 1. Right? If that's the case, negative 1 over 2a is the same thing as this. So we neglect this 0, right? So the next thing we need to do here is that we need to simplify the what? Equation more. So to do that, here is what we need to do. Since we stop at this point, right? We say that what? Negative times negative becomes positive. Definitely E has to be equal to 1 over 2A. A is a constant in the formula. Assuming A is equal to 3, then definitely energy has to be equal to 1 over 2 times 3, which is equal to 1 over 6. Now we know the energy is what? Finite. Good. But we can't conclude that this is an energy signal, right? Or a power, or not an energy signal, because we need to calculate for the power. Now to calculate for the power, remember what the formula says. It says that whenever you find the integral, instead of just taking the limit direct, you take it over the range of what? 1 over 2t. So that's what we need to do. So we need to get the integration. And we said that the integration, if power from the formula, as we said, is what? The limit as t tends to infinity 1 over 2t, right? Then the integration. And we have already calculated for the integration. So what we need to do is that power, which is the limit as t tends to infinity 1 over 2t, the integration from negative t to t, e to the negative at, right? U of t dt. But you already know that e to the negative 2at, right? Negative 2at, which is the integration, is equal to this, right? The integration of this is equal to this. So if that's the case, what we need to do is that p is equal to the limit as t tends to infinity 1 over 2. They will substitute whatever the integration is, which is actually equal to this. Negative 1 over 2a, open bracket, e to the what? Negative 2at minus 1. Right? So after we are done doing that, what we need to do is to proceed. So this can go into this bracket. So we end up having the limit as t tends to infinity 1 negative times 1 over 2t times 2a, right? Open bracket, e to the negative 2at minus 1. That's going to give us what? The limit as t tends to infinity, right? Negative 1 over 4at, open bracket, e to the negative 2at minus 1. Now, the next thing we need to do here is that we need to substitute infinity for t. So the power is equal to negative 1 over 4a times infinity, open bracket, e to the negative 2a times infinity minus 1. So remember that this is going to what? Give us 0. So this will become what? Negative 1 over what? Infinity, right? Times negative 1. 1 over infinity is what? 0. So power is equal to 0 times negative 1, which is actually equal to what? 0. So if power is 0, energy is what? Said to be finite, which is equal to 1 over 2a, and power is equal to 0. What would that be? That is an energy signal, because we know from the definition of energy signal that energy signal has what? A finite energy and what? 0 power. You get the point? So let's solve for the next question.